In today's lesson, we'll be learning how to find the equation of a line with slope and a point. If you recall, a linear relation is really just a pattern, and a pattern can be represented with an equation. These two equations mean exactly the same thing. Rate of change is the same thing as slope, and initial value is the same thing as y-intercept. Slope refers to the steepness of a line, and you can find the slope of a line by drawing a right triangle underneath it and finding the rise and the run. You can also find slope if you have 2 points on that line, and you use the equation y2 subtract y1 over x2 subtract x1. In this table of values, you've been given only two pieces of information. You're told that when x is 20, y is 40. You're also given the slope, which is the same thing as the rate of change. The rise is -3 and the run is +1. I want you to use this information to work backwards to find the y-intercept, in other words, the initial value. Let's get started over here. When x is 19, y is going to be 43. Now, are we really going to work backwards to when x is 0? That would take quite a bit of time. There must be a better way. In this graph, you have the exact same information that you just saw in the table of values earlier. We know that when x is 20, y is 40. We've also been given the slope. The rise is -3 and the run is +1. Over here is the x-axis and over here is the y-axis. I want you to use this information, this point, and the slope to work backwards to find the y-intercept. Now you'll notice that this is going to take a lot of time. There must be a better way, and there is. We're going to be using this equation and algebra to find the y-intercept without using a table of values and without using a graph. Let's get started by listing out some of the information that was given. We know that when x is 20, y is 40. We also know the slope. We were told that it was -3 over 1. -3 is the rise and +1 is the run. Now, -3 over 1 is the same thing as -3 divided by 1, which is the same thing as just -3. Now we can get started by replacing some of these variables with your known values. I'm going to start by replacing y with the number 40. Next, I'm going to replace the variable of m, which represents slope, with the number -3. Afterwards, I'm going to replace the variable of x with the number 20. And the plus b stays exactly the same. This looks a bit strange. This looks like -320. Well, in between these numbers is actually a multiplication sign. My next line of work, I'm going to simplify -3 times 20. The 40 is going to stay exactly the same. -3 times 20 is going to give you -60. Why negative? Well, when you have a negative multiplied by a positive, that's going to give you a negative number. My plus b is also going to stay exactly the same. At this point, you want to look for like terms. You'll notice that 40 and -60 are like terms. Like terms like to be together, which means you can move the 40 over to be with the -60, or you can move the -60 over to be with the 40. I'm going to move the -60 over to be with the 40. Remember, generally speaking, you want to keep numbers and variables on separate sides of an equation. So when you bring a term over an equal sign, it becomes the opposite, which means this is no longer -60, this is now +60. And this plus b stays exactly the same, but I'm going to erase the positive sign since we don't really need it. You want to now simplify the left side of the equation. 40 plus 60 gives you 100. Therefore, the y-intercept is 100, and we found this by using algebra. Therefore, it is possible to find the equation of a line if you're given just the point and the slope. We were given just the slope. It was -3 over 1, which is the same thing as just -3. Now, using this equation and algebra, we worked backwards to find the y-intercept, and that was 100. Therefore, the equation of this line is y equals -3x plus 100.